Monica.
I'm Sierra.
And I'm Grace.
Today we'll be going over everything you need to know to set up the Freezing Point Depression Lab.
We'll start off by talking about the lab's objective, and we'll give you a little bit of background info. Then we'll talk about the lab setup and go over how to collect your data.
The point of this lab is to determine the molar mass by freezing point depression. What this means is that we'll be collecting the data about the temperature at which solutions freeze and work backwards to determine the molar mass of a mystery solute.
The main thing you need to know going into this lab is the equation that shows the relationship between the freezing temperature and the number of moles of solute added. The equation is delta T of freezing equals the freezing point depression constant times the solution's molality times the Van't Hoff factor.
Because we're not dealing with ionic compounds, the Van't Hoff factor I is equal to 1, and therefore it need not be included in our calculations.
The equation can be rearranged to show that the solute's molar mass is equal to Kf times grams of solute all over delta Tf times kilograms of solvent.
Therefore, our data collection is going to be pretty straightforward. We basically just need to find the values to plug into this equation. We already have a Kf constant for lauric acid. We'll measure the masses of solute in solution at the beginning of the experiment, so the point of our data collection is to first measure the temperature that pure lauric acid freezes at, and then measure the temperature that the solution of unknown substance dissolved in lauric acid freezes at. By subtracting those two values, you'll have your delta T.
Before we start, I want to go over a few important vocab words. All of these terms revolve around the lab's central equation. First is colligative property, which describes freezing point depression. This means that it depends on the ratio of solute and solvent particles.
The next term is molality. It's the ratio of moles of solute to kilograms of solvent.
Freezing point depression constant is the unique constant for a particular solvent.
Now we're going to show you how to set up the actual lab. We'll show you how to do the trial with the unknown solute dissolved in lauric acid.
You need lauric acid, the unknown solute, a spark, a temp probe, beakers, and a hot water bath on the ring stand hot plate setup. You also need a cool water bath. Here's how to measure out your unknown substance.
You're going to want to measure out and carefully record the exact amount of grams that you're going to be dissolving in your solution, because that's essential for the calculations at the very end. Don't eat this stuff. It looks like candy, but it's not. Measure out amount on the scale. It crumbles pretty easily, and you can break it up with your hands if you need to. Just make sure that you wash your hands afterwards. And Mr. Ozuna will tell you the amount that you need to use. We're going to be using about this much. So I'm going to show you how to set up the spark. First, you're going to want to take your temp probe and plug it in, and the build screen should pop up. You'll press temperature, the units are in Celsius, so that's what you want, and you'll press show, and it'll come up with a graph. The instructions say to set up the time graph for 10 seconds per sample and 60 samples, so you're going to change that by pressing this icon right here, and periodic, that's the correct mode, but you're going to change sample rate to 10, and then you're going to change the sample rate units to seconds. Automatic stop condition, that's how you're going to get the 60 samples set up. So instead of no condition, we're going to say stop after duration. And since we can't put in stop after 60 samples, we're just going to say stop after 600 seconds, which based on our 10-second sample size should give us 60 samples. So I'm putting in 600 right here. Units are in seconds. I'm changing sample rate. Make sure that's at 10, and we should be good to go. That's all there is to setting up your spark. This is what your lab setup should look like. You have a hot water bath, and you have the lauric acid with the unknown solute dissolved in it, and you're going to want to melt the lauric acid as your first step. So place it in the hot water bath using the clamp so it doesn't touch the sides of the beaker, and wait until it melts. You're just going to want to keep an eye on it. You don't need the temperature probe yet.
Okay, so also, if it's taking a while to melt, you can always use your temp probe to stir it a little bit so it'll go a little faster.
Our lauric acid's melted. It's only taken a couple minutes, and now we're going to transfer it into the ice bath. At this point, you're going to want to put the temp probe in at its hottest point and start data recording.
Make sure you stir the solution constantly and try not to hit the sides with the temp probe. Here's a quick recap of what we've done today.
The most important thing to remember is the freezing point depression equation. It will guide you through using your data and for solving for molar mass.
Remember to record all masses and volume before data recording starts.
And of course, follow all basic lab safety procedures. And make sure you stir the stuff.
Yeah.
Are you holding it? Okay, she's holding it.
Hi. And we're gonna need to redo that. Stop. Put it back in the boiling water. Yeah. Okay, guys, so our lauric acid's melted. It's only taken a couple minutes. Natalie, shut up.
Wow.
Oh my God, Natalie!